my screen and start my slides. There we go. You guys can see that? Cool. All right. Thank you, everybody. Glad to be here to present to you tonight / this afternoon / whatever time it is where you live. I'm coming to you live from Ohio in the United States. My name is Steve Smith. I talk about code quality and domain-driven design and architecture and things like that. I have some courses on Pluralsight and some other things which I'll briefly describe before we get into the topic. You can find me online as Ardalis. And the reason for that is the name Steve Smith is incredibly common. And so getting Steve Smith as a name anywhere is virtually impossible. But Ardalis is usually there for me. Please don't take it. I rely on that. And so on GitHub, Twitter, whatever, YouTube, you'll find me as Ardalis. Today, we're going to talk about applying clean architecture to ASP.NET Core apps. And I have a bunch of resources to share with you related to that. If you want to learn more from me after today, either about this topic or some related topics, you can check out the domain-driven design fundamentals that I did with Julie Lerman, who you probably know from Entity Framework, but she also does a lot of stuff with domain-driven design and other things as well. We're actually looking to redo this course for .NET Core sometime this year, but it's, you know, the concepts are evergreen. They don't change. So you can watch this version if you like, and you'll get a good idea of the principles and things that lead toward this architecture we're going to talk about. There is a free Microsoft reference application that I have written and maintained called eShop on Web. If you just Google for eShop on Web, you'll find it. I'm going to show you some of the code from that at the end of this talk. There's a corresponding book that's a little over 100-page PDF. That's the book cover you see on your screen. If you go to the URL there, it should take you right to it. Or if you go to the eShop on Web GitHub repo, there's links to it from there as well. My company, I have a small team. We do mentoring, training for teams that want to get better and write better code and use design patterns and clean architecture and all that. So if that sounds like you and you would like some help, please feel free to reach out to me. And I also started about 1.5 years ago a developer career mentoring program at devbetter.com, which is more for individual developers that want to accelerate in their career, both technically as well as, you know, personal branding and how to find the right job or how to go independent or things like that. It's not free, you know, it's people that have skin in the game that are involved, but it is a great small group of people that we meet every week. I also have a newsletter and a podcast and some other stuff. I stream on Twitch on Fridays usually when I can. And so there's those. And then let's get started. So if we were all sitting live in a room together, I would say, okay, who has any questions about clean architecture with ASP.NET Core? And I can tell you from experience at a number of conferences and user groups that generally nobody asks any questions. So what I have done is I've anticipated that, and especially now since it's not that easy for you to ask questions, I'm going to just offer some questions that you might have had, and we're going to talk about how we're going to cover those in the next little bit. So the first question that you may be asking, and that I'll be answering in any case, is why do we separate our applications into multiple projects if we do? And then what are some principles that we can apply when we organize our software into different modules? And then if we are going to break up our software into these different modules or projects, how does that organization impact the coupling of our solution and of the software that we ultimately end up building? We'll talk about what some of the problems are that result from certain common approaches. We'll talk about how clean architecture addresses these problems. And then I've been giving this talk for a couple of years now, and ASP.NET Core was new to a lot of folks when I started. So I also cover a little bit of, you know, what does ASP.NET Core do to help this, as opposed to classic ASP.NET, MVC or Web API 2 or what have you. I see some things are coming through in the chat for Zoom. So let me see if I can get that to be up on my screen somewhere I can see it. All right. And they mentioned that we could do questions at the end. I'm actually really happy to try and answer questions as we go, if I see them. And if one of the moderators wants to jump in and just get my attention whenever I stop and say, hey, are there any questions? That'd be great. Otherwise, if we answer them all at the end, then a lot of them are out of context. And I'm trying to remember, like, what was I talking about when they asked this question? And it tends to be a little more interactive for everybody too. So, okay. I don't see anything that looks like an actual question, so I'm going to continue on. All right, so let's talk about some principles. And so the way I look at architecture and the way I try and present it here in this presentation is that there are underlying principles that apply to software development, software architecture, that we can use to kind of evaluate and guide different approaches to architecture or software design. And so if we can get all on the same page about what some of those principles are, or at least I can share with you the principles that I feel are important and that I look to when I think about architecture, then I think that helps inform those decisions. And you may not agree all the time with how I apply those principles or which principles I think are important, and that's fine. But I do think that knowing what these principles are is useful as the sort of underpinning for the discussion. So the first and probably the most important principle that applies to clean architecture is called separation of concerns. And the idea with separation of concerns is that you don't want to let your plumbing code pollute the rest of your software. And so this image here is actually of the refrigerator in our office from our old consulting company, Nimble Pros. We put together a software craftsmanship calendar that we sold every year, and this was from that calendar. And so you can see that this might not be how hopefully your kitchen refrigerator is laid out with some of the contents of it. So there's Drano and a toilet brush and a pipe wrench with your burgers and your meat sitting out and things like that, right? So this is an example of how you would be mixing those concerns together in the same place, and you really don't want to be doing that. It's not really sanitary. So in the terms of software development, right, you want to avoid mixing different code responsibilities or concerns in the same location, whether that's in a method or a class or a project. And so when we talk about these different concerns, that could be anything. They could be different levels of abstraction. They could be different cross-cutting concerns, like for instance, logging or authentication could be examples. But the big three that you typically think of are going to be your data access, your business rules, or if you're doing domain-driven design, that's going to be your domain model, and your user interface. So the minimum breakdown that most folks start with when they're thinking about separation of concerns and how to break apart their architecture is going to be at least these three and sometimes more. Okay? Now then the next related principle is one of the solid principles. And this is another one that was taken from one of our calendar images. And single responsibility principle, if you're familiar with solid, you've heard of this, basically is about not coupling your tools together. And so in this image, it's a little bit dated now because nobody necessarily uses a wired mouse as much as they used to. But this is a wired Swiss Army mouse that you could use. So that if you ever needed to have a wine corkscrew or bottle opener, while you were at your computer with your mouse, this multi-tool had it all. Probably you'd be better off having a separate tool for your mouse and your Swiss Army knife needs. And so that was the idea here. And in your software, it's not unusual to have God classes that seem to do everything and have way too many responsibilities. And the problem with those is that anytime you need to change one of those responsibilities, you have the chance of messing up or breaking any of those other things that class does or that method does. And so the idea with single responsibility is that it works very closely with separation of concerns. If you follow these two principles, it should lead you toward having smaller classes that only focus on one thing. And so one of the ways that you can paraphrase the single responsibility principle is that your classes should only have one reason to change. And so if you think about that from a requirement standpoint or stakeholder standpoint, there should only be one requirement for your system that if that requirement changes, then it would have a one-to-one correspondence with this class, right? And if two different requirements change, they shouldn't both be different ways that could modify this class if you can help it. There's limits to how much you can do that, but that's the general idea. All right, so then the next really fundamental principle of software development is the don't repeat yourself principle. And so here, obviously, we've chosen to repeat ourselves in telling you that you shouldn't do that. The issue with repeating yourself in software tends to be that if you have to change the fundamental logic of something, and you've repeated that logic in more than one place, the odds are that when you have to make a change to that logic, you're going to miss some of those places. And you're going to update it in several of them, but not all of them. And now you have inconsistent behavior and you've introduced a bug in the system. So when you follow the don't repeat yourself principle, typically what you do is you take duplicate logic that really is fundamentally the same logic, and you refactor it into functions or methods. Then, of course, we're going to group these into classes because we're in an object-oriented language of C# or perhaps VB.NET. And then we're going to group these into folders and namespaces by responsibility, level of abstraction, whatever makes sense to us as we're building it. And then ultimately, we'll probably group these into projects. And we'll talk about why we want to group them into projects and whether projects are necessary in just a few more minutes. Now, bookending the other end of solid is the D in the phrase, which is the dependency inversion principle. And the dependency inversion principle, I think, is the most important of the solid principles. It should really be at the front, but the DILOS or DALIS or whatever acronym just didn't catch on as much as solid. And so it is where it is. But the image here is of taking a lamp and like directly soldering it into the electrical circuit running in the wiring in your house. If you then want to move your lamp or you want to plug something else there instead, you have to cut the wires, you have to resolder everything, or at least tape it all up and use wing nuts or whatever. It's a lot more dangerous and a lot more of a hassle to modify where your appliances are inside of your house at that point. So what do? Well, we have outlets. Now, your outlets may not look like my outlets do, which look like the ones in the picture here, but they serve the same purpose of providing an interface that allow us to literally use plug-in technology to be able to modularize our appliances and switch out which thing we want to have plugged in at a given time. And on a related note, I've got a course on Pluralsight called the adapter design pattern that talks about what to do if you find yourself in an appliance in a location that doesn't have the correct interface that you want, and how you can use an adapter to solve that problem. But that's a story for another time. So with the dependency inversion principle, the idea is that your high-level classes and your low-level implementation detail classes should both depend on abstractions, not concrete implementations, not specific details. And in the .NET space, when we talk about abstractions, typically we mean interfaces. Sometimes we'll mean abstract base classes or even just base classes in general. But by and large, interfaces are the more flexible thing that we want to depend on because we have multiple interface inheritance. And so it doesn't cost us anything to add something that implements a particular interface. We can do that for free, essentially. Related to the dependency inversion principle is another less well-known principle called the explicit dependencies principle. And this is less well-known probably because I made it up and I try and tell people about it, but it doesn't have somebody like Uncle Bob Martin behind it. But the idea with the explicit dependencies principle is that your classes that have dependencies should be explicit about them. They should request all of those dependencies through their constructor. And what this does is it makes your classes very honest about what they need to do their job. There's a corollary to this, which is if you're not being honest about what you need, your classes are sort of being deceptive. And they're saying, okay, you could just new me up and I don't need anything. But then at runtime, it might blow up for this or that reason. So tell me if you've ever run into this problem where you're in a code base you're not necessarily familiar with, you're starting out a new job, or you just switched over to a different project, and you have to perform some task, and you're pretty sure this thing's already been done before. You don't have to reinvent the wheel. Somewhere there's a service that does what you need. So you scan through and you search and you find this service that sounds like it does what you want, and it's got a method that looks like the right one, and you look and you see, yes, you've got the things the method needs. You check the constructor with IntelliSense. Oh, look, I can just new it up. Great, doesn't need anything. So you new up this service and you call the method and you pass it the things and everything compiles and you're like, great, I'm going home early. And then you run it, and at runtime it just blows up and it says something like, oh, I could not find this setting that I need in configuration, blah, blah, blah. Or you go track that down and you fix it and you run it again. And now it says, oh, I don't have this file that I need at this path that you didn't set up and blah, blah, blah. And so now you're having to go into the code of that service and read through line by line and try and figure out, what does it need? What does it need here? Oh, it also needs this, and it's coupled to that. And it's making it way harder for you to actually just use this service without having to know all the details of how it works. By being explicit about your dependencies, you avoid that problem. Right? When you go to use that service, you look at the constructor, it says, oh, I need an I connection setting and I need an I file location or whatever, a couple of interfaces to access these things. And you could create those or gain access to them, but you know up front that you need to provide them, and you aren't surprised with them at runtime that something is wrong. All right. Let me pause for just a minute and take a sip of water and see if there's any questions that I need to address. I see lots of discussion, which is great. I don't see anything that's a specific question that I need to do anything with, so I'm going to keep going. All right, so related to this, it's a good idea to invert and then inject your dependencies. When you're doing dependency injection, by the way, that is the strategy design pattern. So if you're well versed in dependency injection, but you don't necessarily know a whole lot of design patterns, congratulations, you know the strategy pattern. So you can just keep that in mind and throw it on your resume. Maybe go watch the Pluralsight course just to verify, but dependency injection and the strategy pattern are basically the same thing. So the corollary for if you're going to follow the explicit dependencies principle and you're going to follow dependency inversion, and you're going to say, I'm going to have these services, they're not going to just instantiate their dependencies, they're going to request them through their constructor, and they're going to be injected as concrete implementations of these abstract interfaces. Those interfaces have to be defined somewhere. And the low-level services that implement them have to know where they are, obviously, right? They have to be able to reference them. The high-level services that are requesting them through their constructor have to be able to access them as well, because they're going to define them in their constructor. And then when you start your application, your user interface entry point is typically where you wire all that together. If you're doing ASP.NET Core, typically this happens inside of startup.cs, inside configure services. That's where you do all your wiring up between interfaces and the services that are going to implement them. And so that's also a place that needs to know about these interfaces. And so we'll come back to this in a minute when we talk about where should interfaces live, because I see a lot of confusion on that front in terms of like where people want to define interfaces that their services are going to implement. All right, let's talk about why interfaces are important and what dependency inversion does for us. And this is something that was a real epiphany for me. I still remember the day that I learned this, and it was not in college, and it was not my first day as a software developer. It was years after being a professional software developer that I finally figured this out. So if you're relatively new to writing software and you figure this out early, you'll be way ahead of me, which is good. Okay, so here it is. If you just use the new keyword to new up your dependencies, your compile time references look like what you see on the left. All right, class A is going to new up class B and call some method on it. Inside that method in class B, it's going to new up class C and call some method on it, right? Or if we don't even use new, this could just be static calls, right? A calls a static method on B, which calls a static method on C. Has the exact same look. On the right, this is what it looks like at runtime. Right, if you put a breakpoint in class C and you look at your stack trace, you're going to see method in class A called method in class B called method in class C, and they are the same. All right. Now, if we use interfaces, then you have this option to break that chain. Right. On the left now, class A knows about some interface B and calls some methods on it, but has no knowledge of class B. And class B's method, likewise, calls interface C, but has no knowledge of class C. And so at compile time, you have this much more flexible approach where you could swap in and have a plug-in architecture where maybe we don't want class B to be the interface B thing. Maybe we want B prime or whatever, some other implementation, a mock of B or a fake B during a test. And you can easily swap that out. On the right, the runtime behavior is identical, right? Assuming that you implement B and C just like we did the first time. So class A can still call into class B, which can still call into class C, but we're going to wire that up at runtime to say which interface goes with which implementation detail. And that turns out to be extremely effective at reducing coupling, and it allows us to add seams to the code. And seams is an idea that Michael Feathers introduces in his book, Working Effectively with Legacy Code, which I have on my shelf up here. And what seams allow you to do is break apart your monolithic application that has all this code that runs together and has to run together, and allows you to test little pieces of it in isolation from one another. And that turns out to be really important for testability, but also for just general maintainability as well. All right, so then this question about vertical slices is somehow a variation of clean. Is that a correct understanding? Each project is different, but one of these two architectures is a good fit more than the other for a large code base. So Jimmy Bogart has a presentation he's been doing for the past couple of years called Vertical Slice Architecture. I have a principle that I talk about for years called vertical slices as being the way I like to deliver features. And they're kind of related. They're very similar. What he talks about when he presents vertical slice architecture is that he makes each thing that he's developing just be everything in one vertical slice, from the API endpoint to the code that it's using to do the logic to the data access. Basically, it's like a mini program altogether without dependencies on all the other slices. And so he doesn't do a lot of full layering necessarily with different projects and things, because he just keeps everything really simple in one tiny little handler for an API. And that works fairly well for what he's doing, and it's a perfectly valid approach. He is the author of the open source tool Mediator, and Mediator lends itself toward this architecture because you can create commands and handlers and pipelines that let you kind of define that vertical slice. I have there's a lot of overlap between the two. Like the ideas between them are similar. There's a couple things that we disagree on. Like he is perfectly fine to just be like, I'm gonna hard code all my dependencies to data access, and it's okay because I'm only gonna do it in this one slice. And if I need to change it, like for this other endpoint needs something different, well then I'll just use a whole different data access technology for this other slice than this one over here. And so he has that flexibility with that architecture. I don't generally need to do that. I don't generally have different data access needs between different endpoints in my API. And if I do, I've found that it's not that difficult to wire up my IOC container to accomplish what I need for that. But it's, you know, a few different tweaks and optimizations on how he does it. So I don't want to speak too much for him. He's got presentations you can watch on YouTube, and I respect the heck out of him. So, you know, look at both and evaluate which one is a better fit for your system. And I don't think you'll go wrong with either one. Okay, so one of the things that I want to focus on in clean architecture, the way I develop software, is I want to make it so that it's easy to do the right thing and it's hard to do the wrong thing. Because if you make it easy to do the wrong thing, but you tell developers, oh, don't do that, even though that's the easy way, be disciplined, right? Don't do that. Developers are lazy, right? Developers are going to do the thing that's easy when they just need to get the job done because it's time to go home, or the customer's saying they need this feature right now. And so we want to kind of force developers into the pit of success and not have it be so easy for them to just, you know, copy paste code or just new up a data context and write the code to talk to the database directly right there inside the controller, right? Because if you do that too much, that leads to the pit of despair, in my experience. And so we want to avoid that. We want to make it so that you can do the right thing and not end up in the pit of despair. Okay, so what are some things we can do to make the right thing easy and the wrong thing hard? Well, first, I don't think your UI classes should typically depend directly on your infrastructure classes, because I want that to be flexible, right? I want to be able to swap out what infrastructure I'm using with some other implementation, either wholesale for the whole project, maybe so I could do some integration testing against a fake backend, maybe so that when I'm doing integration testing, I'm not actually sending emails to my customers, you know, things like that. I'd like to be able to swap out my actual email sender with a fake email sender. And so if that were loosely coupled, it would be great, because then I would be able to have better automation capabilities and automated testing capabilities. So let's think about how we could structure the solution to make it so the UI classes don't depend on it. Now, likewise, I really want to be able to test my business logic. My domain, my core domain model that I'm doing in DDD needs to be super testable, because that's where all the complexity is, where I'm modeling this complex business logic and all these business rules that say how things are supposed to work and what things are valid and what things aren't and what state the system's in and all that. I don't want that to depend on infrastructure either. I don't want that to be tightly coupled to a database, so the only way I can test it is by having a test database that I restore to a known good state before every test, because that leads to pain, right? That's the pit of despair, and I've been there, because when I first started doing TDD, I didn't know how to do these things. And so the only way I knew how to do it was to have a test database that I reset before every test. And after about 100 tests, the tests would take a few minutes to run. And it just got worse from there. And so your feedback loop gets really slow when every time you're making a big change and you want to see if you broke anything, you have to wait, you know, 5 or 10 minutes to get that feedback. The nice thing about unit tests is you should be able to run thousands of them in a couple of seconds. And so we would really rather get that feedback rapidly with unit tests, and we can do that if we don't depend on infrastructure for those business logic classes. And then repetition, that don't repeat yourself principle, tends to be a common problem also. And so we want to find patterns that we can use to eliminate repetition when it's literally the same concept. Now, you have to be careful of eliminating too much repetition, because when you eliminate repetition, you're also introducing coupling, right? And so there's a fine line you have to walk here of where to draw the line on this, because you may want to have some duplication to allow different applications or different parts of the same application to evolve independently from one another. And so when that's the case, you want to have that duplication so that they can remain independent and not be tightly coupled. But in the case where you have policies that you want to enforce, you have cross-functional requirements that are in place, like how we do logging, how we do error handling, things like that. It would be great if you could apply those policies globally on your system without having to copy paste if blocks on every single action method inside your controllers. All right, there's got to be a better way to do that. Okay, so let's talk about a couple of different ways we can split things up. The first one is this classic n-tier architecture. And this is what most developers from, let's say, 10 to 20 years ago were learning about and were doing as the best practice of the time. And I can tell you that because this was Microsoft's best practices from their website from 2001. And this was in like literally my first conference talk I gave in September of 2001 to a huge crowd of 6 people because it was a week and a half after 9/11 and nobody wanted to get on an airplane and go to a conference. And so there were more speakers at this conference than there were attendees. But I gave a talk on this exact topic on how to do n-tier architecture, and it was my first ever conference speaking experience. On the far left is the so-called classical approach that most applications were being written in the day of either classic ASP, VB script pages, or VB6, WinForms style applications, or early .NET, a couple of years after this, when first versions of .NET came out. You're building web forms and everything was in page load and button click, and it was just talking straight to the database. And the idea was you wanted to break that up and have a separate data access layer and a separate business logic layer, because then you could get some reuse and you could have different teams working on different things. You could have, the person that was really good at writing data access logic could focus on the data access layer, and then everybody writing the UI and the business layer logic could benefit from that, could make those calls. The problem with this, though, turns out to be transitive dependencies, because at the time, interfaces were a thing, at least once we got into .NET, not so much with VB script. But in early .NET languages, C# had interfaces from version 1, but most developers that were building these types of applications weren't using them the way they should be. And so you had these direct relationships where the data access layer directly called the database, the business layer directly called the data access layer, it newed it up, or it was a static call. And so it transitively depended on the database, and the UI layer did the same thing with the business layer. And so everything ends up depending on the database. And when everything depends on the database, the only way you can test any of it is with that test database. It just gets slower and slower, and it just sucks the life out of you when you're writing code and you're trying to get stuff done quickly, but every time you need to do something, it just takes all that extra time and friction because you got to deal with this database. All right, so what's the alternative? Well, the alternative is that instead of the database is the center of the world that everything else depends on, you change that around and you say, no, let's make it so the business logic, the stuff that's the most important thing we want to test and make sure we get right, let's make that the center of the world. And then everything else depends on it. All right, and so if you're following domain-driven design, this kind of makes sense, that your domain model is going to be the main focus of your effort. And so your domain model consists of not only your business logic, but also object-oriented objects that contain both state and behavior, right? And so this model is composed of entities, interfaces, domain services, and more, and we'll talk about more in a few minutes. This is also where you're going to have the interfaces defined for working with these domain objects. So if you need to get an entity from persistence, there's going to be an interface for that inside of the domain model. And the user interface is going to use those interfaces to interact with the domain model instead of talking to the database directly. Everything in the application, including all the infrastructure, all the low-level plumbing code, and the data access code, depends on these interfaces and also those domain objects. All right? Thanks for the Princess Bride gifts. Oh, of course. All right, so let's talk about clean architecture now. And we'll shift over to how this plays into this. You may already be familiar with clean architecture under another name. So Jeffrey Palermo, a friend of mine, wrote some blog posts like 10 years ago on onion architecture, and he kind of drew the picture with concentric circles like onion layers. It's basically the same thing. Before that, there was hexagonal architecture. We'll talk about why it was called that in just a minute, as well as ports and adapters. All of these are essentially the same idea, the same architecture with very minor differences. All right, so here's a diagram from Jeffrey Palermo's Onion Architecture posts. And the three middle circles there, the ones that are not purple, represent the core of the application. And so at the very, very center, you've got your domain entities. These are the things that represent stateful objects in your system. This is customer and order and cart and policy or whatever it might be that you're building. And around that, you access those domain entities. Typically, those get saved between requests or over time or between application starts in some medium, right? In a database, probably, right? And so you have repository interfaces that control how you get and store those entities to and from persistence. And then you have service interfaces around that that dictate how you might work with these entities and use those repositories. Now, that doesn't mean everything has to go through a service. You can have stuff that talks directly to domain entities after they get it from a repository. But the general idea here is that those three things control the domain model. And then everything else lives around the outside. So you've got your actual UI, whatever your client is, that's ASP.NET Core, that's it could be WCF, it could be anything. All your infrastructure is on the outside. So how you get stuff from the database is probably a repository implementation that lives in the infrastructure project. How you do logging, how you send email, how you talk to a file, all that stuff's infrastructure. All your tests live outside of this too, of course. All right, another view of this, this one's even older, is here. This shows you ports and adapters as well as hexagonal. The reason why it's called hexagonal architecture, as far as I can tell, is because somebody thought it was a cool idea to use a hexagon on this slide. That's it, right? If they'd used some other thing, we'd call that architecture something else. In here, you can see these like 4 purple circles. Those represent the ports by which other things plug into this architecture, into this domain layer. And so in the top right, you've got this internal persistence port that says how the domain layer is going to persist itself. It could plug in a remote database management system like SQL Server or Oracle to store those objects, or it could just store them in an in-memory store, maybe for a test, right? Either one of those modules could be plugged in and swapped out one for the other. That persistence port, we would call that a repository interface, right? And those would be repository implementations. And why is that? Because the entire meaning of repository is it's a pattern for abstracting persistence and then being able to plug in different persistence options. That's what it is. Okay, so then you might have an application layer. You might have different UI front ends that come through a different port. The idea here is that you expose these different ports or interfaces, and then other parts of the application implement those interfaces. All right, so the rules of clean architecture are pretty simple. The first rule is you don't talk about clean architecture. I don't know if all of you have seen Fight Club, but it's a good movie. But that's not the right rules for clean architecture. The first rule is that the application core should contain the domain model, and only the application core has all the domain logic in it, right? So it shouldn't bleed out into the UI. It shouldn't be in the infrastructure project either. Everything should be in the core project, and then all your dependencies depend on the core project. So if you're using the onion circle diagram, everything points inward toward the inner circle, and the innermost circle is the core project in your system. So related to this, your inner projects have to define interfaces, and then your outer projects implement them. All right, so this is a corollary to that rule, because we have to have the interfaces defined in an inner project so that outer projects that reference those can access them. It wouldn't work the other way. I couldn't put interfaces in an outermost project and then try and work with those interfaces on the inside, because the dependencies wouldn't let me do it. All right, so it has to work this way. You want to avoid direct dependency on the infrastructure project. Probably the 2 exceptions to this are going to be integration tests that verify that those things work correctly, as well as in startup.cs, when you're wiring everything up and configure services, you might have references to it there. It's not required, and there's ways you can get around that, but it's typically what you will do. All right. Some features of clean architecture. It's really just a pattern. It's totally independent of framework. So I'm going to present this with specific examples using ASP.NET Core, but you could use the same approach if you were using Java or Python or what have you. It doesn't rely on a particular NuGet package or library or anything like that. It's database independent. In fact, it doesn't care if there is a database at all. This is true of domain-driven design in general, is that databases are just sort of arm's length, concern. Like, yeah, at some point we have to store this state of our system and then we'll get it back later. But I don't really care how. Right? I could store it in a blob of JSON on the file system, or I could, use a NoSQL MongoDB, or I could use SQL Server. It doesn't matter, right? It's just a place to store stuff. So if you're coming from a world where like the database is the center of the universe and the most important thing, and everything has to protect the database, that can be a little bit jarring. And for some applications, it makes sense for the database to be the center of the world, especially if it has to do with reporting or analytics or big data or things like that. Those aren't necessarily places where DDD shines, right? But if you're building something that has a lot of complex business logic, and you want to model that in your software in a way that is easy to change and maintain over time, then domain-driven design could be a good approach. And if you're following that, then the database is just one more dependency. And the more arm's length you can make that dependency, the more flexible your architecture will be. And of course, it's also UI independent. It doesn't care whether it's ASP.NET Core or a worker service or AWS Lambda function or whatever. Something is going to be the entry point to your application, and it doesn't really matter what. Because of the approach to clean architecture, because of those rules that say all of your domain layer and all of your business logic is at the center, and all of your things that have dependency on infrastructure and external things are out the outside and they depend on it, it's extremely testable. It's one of its best features, one of the things I like best about it. I think manually testing your code is generally wasting your time and your client's money, because developers are expensive, and every year they get more expensive, at least under current market dynamics, and computers are cheap, and every year they get cheaper because of Moore's law and other things, right? So why would you make it so that your system can only be tested by humans if there were a way that you could allow it to be tested by computers that get cheaper and cheaper over time? It just makes good business sense, and companies that embrace that are going to be more agile and better able to respond to threats and changes in the market than companies that require loads and loads of staff to manually test their code, or that rely on customers to test their code for them in the market. All right, so let's say you have decided that clean architecture is worth checking out, and you have an existing system of some sort, and you want to refactor it to start using this architecture. Well, there's basically three places where you might start. The first one is that you're doing a greenfield application. You don't have any code, or you've got the green light to rewrite something as a new version, a new, better version of the old thing. In that case, I would recommend you start from a properly organized solution. There's a few different samples out there that you could start from. This is mine. So you can clone this Git repo and basically use it as if you were in Visual Studio and you said file, new, clean architecture. As a matter of fact, there is actually, if you go to this URL, an add-in that you can use to make it so you do in fact have a solution template in Visual Studio where you can literally do that and say file, new, clean architecture. Next best is if you have an application that already exists and everything is in one project. Ironically, even though that's less well organized, it's actually easier to migrate because everything is in one place, so it's easier to pull stuff out without having to worry about how it's all going to fit together and what all the dependencies are. Generally, in my experience. The hardest place is where you've got a multi-layer architecture, but it doesn't use abstractions and it doesn't use dependency injection, and it's not using the DI, dependency inversion, right? So you've got that classic user interface, depends on the business layer, depends on the data layer, everything depends on the database. That will be the most expensive to re-architect. And if it's really complex and it's not your team's forte to do things this new way, it might be a good idea for you to get some help to do it. Either just training and then your team can do it, or someone to kind of hold your hand as you get through the process until you've got your legs under you, and then you can run with it. All right, let's see, any questions? Nope, nothing new there. All right, and I go pretty fast through the slides, and we're mostly done with the major parts of the slides. There's a few left. This is where the real meat of what goes where is going to be, and then I want to get to the code. Right, so I don't want to totally have your eyes all glaze over and be looking out the window at what a nice day is outside before we get a chance to see code. So that's why I'm going so quickly. This is all recorded, so if I go too fast for you, just go back and review the recording. I'll make sure that the slides are available as well, so that'll all be there for you. Okay, so what actually goes into this core project, this domain model? You should not have any dependencies. So if you look at like the project references, there shouldn't be dependencies on things like, system.data.sql client, where it's going to be talking to the database directly, or even EF core. or if you're older .NET, just standard entity framework. Instead, you should have your interfaces that we've talked about, and we should have your domain model types, which are mostly going to be things like entities and value objects, and perhaps aggregates if you're using that pattern. Aggregates are a DDD pattern that lets you group related entities together so that you persist them as a unit, either saving them or retrieving them from persistence. You'll have domain services, which will have logic in them that generally affects multiple entities or aggregates and doesn't really belong on any one of them. I suggest that you have custom exceptions, and those exceptions live in your domain layer. Custom exceptions are great for like known exceptional things that might happen that really should never happen because your UI or your API or somebody should have caught it before it got here, right? So you've got something like I've got a customer and I want to add a new order to it. Okay, well, what if order is null? Well, that should throw an exception, right? You should check for that and throw an exception. Should you just throw a null reference exception? Well, that's not great because as the developer who has dealt with null reference exceptions a time or two, I can tell you that they're one of the most frustrating things to ever get back in your exception log, right? Because they don't ever tell you what was null. So wouldn't it be much nicer if it said like, order does not exist exception or something like that, or even just an argument null exception and tell me that it's order, as opposed to not doing any exception at all, right? And as soon as you say, order dot ID or something, now it blows up because you're dereferencing that null. Give it a real exception that's at the domain language level, not at the primitive, this pointer didn't point to a real thing level, right? That's too low level for your domain model. Your domain model should be telling you things at the level of the business domain, not at the low level computer architecture domain. All right, related to the domain model are domain events. If I were to ask who's using domain events, usually I don't get a lot of hands, although that number's been going up steadily over time. I don't think I have an easy way to poll people, and I don't want to flood the chat, but domain events are an awesome pattern. If you've not used them at all, I would encourage you to check them out. They are used in the two samples I'm going to show you today, so you can look at those to see how they work and how they're wired up. These are a great tool, a great pattern for decoupling when X happens, then Y should happen, right? And so if you have situations in your code where some big thing happens, like the customer checks out, okay, well, when they check out, we got to do a whole workflow of stuff, right? We got to make sure we save their order. We got to make sure we check to see if we have the inventory. We got to charge their card. We got to send them an email. We got to, write a delivery slip, print one of these packing slips up. All this stuff has to happen. Do you put all that logic inside the controller action or in the button click event for when they click checkout? Or even if you've got a domain model and you've got an order object and it's got a checkout method on it, do you put it all in there? Because it just keeps getting bigger, right? The customer stakeholders, whoever's in charge, they're going to keep coming up with more requirements for this, right? There's going to be yet another thing that we need to do whenever the customer checks out. And that method is just going to keep getting bigger and bigger and bigger. Domain events provide a way to avoid that, right? Domain events are, okay, I'm checking out this order. Save the current state of the order and note that it's now in a checked out state or whatever. Make sure that that saves successfully, and then raise an event that says order checked out. If you have ever bought anything from Amazon, and this is where everybody's hand goes up because of course, you would notice that when you check out from Amazon, you get back a screen that says, thank you for your order. Here's what you bought. It's this much. You bought these 3 things. They cost this much. Here's your tax. Here's when you can expect to get it, right? And at this point, most people in the room will be like, yeah, sure. And then I will say, no, that's not actually what you get, right? When you buy something from almost any other store on the internet, including Amazon subsidiaries like Woot, yes, you will get that. You'll get a receipt on the page that says exactly what you bought, but not on Amazon. On Amazon, what you'll get is, thanks. And that's it, right? It doesn't tell you what you bought, right? Now, soon you'll get an email that says what you bought. And sometimes that email will say, we don't actually have it. And sometimes it'll say your credit card expired. And sometimes it'll say something else. But they don't actually do a whole lot when you check out, right? They just fire off an event. And then some other thing comes along and processes that event and does all the extra work later, not while you're sitting there waiting for the browser to refresh. And so it turns out that like using events in this way is a very flexible way, not only to make it so that your model is more testable, but also to allow your system to scale. It gives you a lot of flexibility there. Those events and those event handlers should live in your domain model. And then specifications, these are another pattern, usually associated with domain-driven design. I'll show you an example of what they look like in a minute, but the short version is a specification is a way to encapsulate a query into a class. And so you would have a collection of different specifications that correspond to the different types of queries you typically need to make against your domain model. And then these specifications would work with your repository to make it so your repository doesn't get huge and bloated. Because if you are using a repository pattern, or if you have used it in the past, perhaps one of your complaints about it was that over time it just got bigger and bigger and bigger, where it was like, okay, first I had list customer, but then I had to have list customer with orders, and then I had to have list active customers, and then I had to have list active customers with orders, and yada, yada, yada. And it just kept getting bigger and bigger, right? Or I had to create, all these different repository classes that each knew how to query each different entity a different way. If you use the specification pattern in concert with the repository pattern, your repositories will stay really thin and really small and focused on just what they do. And all the logic of querying will move into the specifications instead. All right. All right, so that's the core project. That's pretty much everything. Yeah, everything. That's what you would put in core, and we'll see that in code in just a minute. Next, we have the infrastructure project. And the infrastructure project is where all the plumbing code goes, right? If it talks to something that's not in your memory space, that's not running your code, then it belongs in infrastructure. And that includes things like repositories that talk to the database. If you're using caching with your repositories, which I would encourage you to do, because if you're not, you're probably just wasting cycles asking for the same data again and again and again from the database, even though it hasn't changed. So your cached repositories would also go here. Any other web services that you talk to, whether they're your own, if you're doing like microservices and you've got services that talk to services, those clients would live here. Or if you're talking to other, third-party things, if you're talking to the GitHub API, you're talking to SendGrid to send emails, your web API clients would live here to talk to those external systems. If you talk to the file system, if you have your own logging adapters, those would all live here. Things to send email or SMS or Twilio, that kind of thing. If you have logic that depends on the system clock and you want to decouple that so that you can actually run your tests any time of day and not just when the clock is right, you'd want to put your implementation of your clock abstraction in infrastructure. And then any other services that you might have here, including things that are specific to a third-party SDK, like an S3 AWS SDK or an Azure blob storage SDK. Those might have interfaces with them as well. So I mentioned that all your interfaces primarily should go in core. Some interfaces will go in infrastructure sometimes. And what decides that, what makes that the case, is if those interfaces through their parameters or their return types have dependencies on infrastructure concerns. Like I have an interface that returns an AWS blob object. Or an Azure blob object, right? I can't put that interface in core because now core has to know about Azure blob objects, and that's an infrastructure concern. So core can't have that interface. So if I need that interface in that service to live somewhere, I have to put it in infrastructure. Now, ideally, it won't leak beyond infrastructure, right? I'll just use it internally to something inside of infrastructure, but it could live here where that code would be, all right? All right, so then we have the web project, assuming we're doing ASP.NET Core, right? And so it's going to have all your MVC stuff like controllers and views or razor pages. It's going to have all your DTOs that you use to work with those things, like view models or API models or binding models or whatever you call your DTOs that go over the wire. Incidentally, you should not call those entities, and they should not be your domain objects or your data context entity objects, because there's a bunch of reasons for that. Security, performance, tight coupling, etc. You should have different types that are dedicated to your wire protocols that live in this layer. You might also have other low-level MVC things like binders, custom model binders, custom filters, custom helpers, tag helpers, HTML helpers, and you may have other services that live in the UI layer and probably have interfaces that go along with them. Why would there be interfaces and services here? Well, if those interfaces, through their parameter list or return types, depend on any of the things you see on this screen, then they have to live in the web project, because infrastructure doesn't depend on web and core doesn't depend on web. So they can't live in infrastructure or core. They have to live here. All right. That's the third project that you'll typically have in every solution, right? Your clean architecture is basically these three projects. Now, if you have multiple solutions, you're building multiple applications in your organization, you might want to share some code between them. And so in domain-driven design, there's a term for this. It's called a shared kernel. And a shared kernel is just code that lives and is shared by multiple different applications, multiple different bounded contexts inside of your shared domain. My recommendation, and I've done this with a bunch of different companies and it's worked out well basically for all of them, is that you should distribute these types of shared code using NuGet packages. And the biggest reason why you want to use NuGet packages is that they support versioning. And so you decouple when you have to update everything. If you aren't using NuGet packages and you have shared logic between solutions, the typical approach that I see is that every different solution has that shared project in it that's literally just linking to the same thing in source control, right? Maybe they're all in a mono repo, and I don't mean repo like repository pattern, I mean like GitHub repo, where everybody's in the same repo and the shared folder is just like hot linked in to each solution. Or they could be using some way that they're copying that around or whatever. There's different approaches to depend just on the code. And the nice thing about when you do that is you can debug into it simply. And if you do make a change, everybody knows about it and it gets broken really quick, right? Because it's right there in the code for everybody. So those seem good, but the problem is that it totally couples any breaking change with every single other thing before you can ship it. And so if you have, let's say you have 4 teams and one of them needs a breaking change for their release, they can't actually release until they make sure that the second, third, and fourth team are all good with the change, because as soon as they make it, everybody's broken, right? Nobody can work. All right, so it requires a lot more collaboration between the teams. You don't have any independent ability to just ship things that you need. With NuGet packages, you could say, okay, well, everybody's on version 1.05. 2.0 has our breaking change. We're going to depend on 2.0. Everybody else keep working with 1.05 and you're fine, right? And now you can ship, and then they can upgrade when they need to, when they have time, and it makes sense for them to take in that breaking change. All right, so what might go in here? This is going to be things like base classes that your core project uses. They might be base entity, domain event, specification types, common exceptions that you use everywhere, common interfaces that you use everywhere. Authentication is very frequently something that is shared between solutions, so that might go there. You might standardize on a particular DI library like autofac or something like that. Anything you have that's helper methods, extension methods, things like that could live here that kind of facilitate that. If you standardize on a particular logging package, that could go in here as well. Common guard clauses for company-wide requirements that you check all the time could go in here. And most of these things everybody knows, but guard clause is its own pattern that a lot of people haven't heard of. So let me talk about that for just a second. So here is one way that you can check things in a method to do defensive coding before you actually do your work, right? And so in this example, you've got a method, it has 2 different arguments. We want to make sure that order is not null and that customer is not null, because we're going to work with those types. And so we check them just like this, right? And this is an example of what not to do, because you can see that the exception handling code and the error checking and the conditions just kind of obscures the actual work that's going to happen there, where it says process order here, right? And this gets worse if you have more arguments, right? Just 2 arguments is not that bad, but if you have 5 arguments, right, now it gets this huge nested arrow-shaped nested if thing. So a guard clause is just a simple pattern that says fail fast, right? Do the check up front. And so you can do something like this. You say, if order is null, then throw a new argument null exception, blah, blah, blah. And same thing with customer. Now, if you make it down to this section here, you're no longer inside an else block, right? You're just in the only path there is, and it's much easier to follow this. This, it turns out, has a fair bit of repetition, and there's no easy way to hook into it. So if you later change your mind and you're like, well, I don't just want to throw an argument null exception, I want to also log something, or I also want to do something else in this case when these fail. You don't want to have to go through and touch every one of these places where you did this after you've been writing code for months or years. And so it's a good idea to encapsulate that into an abstraction of some sort. And so I've done this enough times that I've created a NuGet package that is just these different guard clauses. And they will check for common things like null or out of range or empty strings. But they also are extensible, where you could have it check for anything you want. Like you could have a invalid customer check or whatever, and throw that in there as a guard clause that you've written. And it's just an extension method that goes and hooks into this framework. And now you can do this guard.against.invalid customer call. And if you ever need to change how that logic works, what does it mean to be a valid customer? What exceptions should I throw when that happens? You only have one place to go to change it now, right? You don't have to go touch every single method that was ever doing a check like this. So things like that are common across many solutions would also go inside that shared kernel. All right, I don't see any other question. Oh, wait, there's a Eric asks, is the core project similar to a .NET Core abstraction assembly? A little bit, because it has the interfaces in it, but the abstraction assemblies typically only have interfaces. They don't have the actual implementation and logic in there. Your core project is going to have those abstractions. It's also going to have all these other things here that are more than that, right? So yes, it has interfaces, and that's important, but it also has the whole domain model of entities and aggregates and value objects and domain events and all that stuff. All right, so back to where we're about to go. I hope that answered the question. We have the solution structure now that looks like this. So if we're not following the circles layered onion approach, and we use a standard like stacked thing where things on the bottom are dependent on by things above them, we have core depends on shared kernel. Shared kernel ideally is a NuGet package, so we can swap out which version we're depending on without breaking our peers, our other teams building other solutions. We have web that depends on core because it has to use those interfaces. We have infrastructure that depends on core because it has to use those interfaces, has to implement them. And that's it, right? That's the whole dependency structure, except that at runtime, we can't just run this thing with nothing but web and a bunch of abstractions in core. We actually need that infrastructure to run. So at runtime, we have to have a reference to infrastructure from web. We might have that at compile time too. We might just make it easy and have a project reference. But if you do, then developers might decide to just new things up from infrastructure inside of web or request them in the constructor. And so you're kind of like leading them into that pit of despair, right? You want to make it so that they can't actually even do that if you're really wanting to enforce this. And so at that point, you can make it so that the infrastructure DLLs or assemblies get copied into the web bin folder as a post-build step, and then read using reflection, which all the DI containers support. You know, it's easy to set that up. And now web can actually wire all that stuff up without even having to have a direct reference to it. And so it's impossible for a developer on purpose or accidentally to use an infrastructure low-level plumbing type inside of web directly, right? The only way they can access it is by implementing an interface that's defined in core. Now, like I said, I don't see a whole lot of teams that actually do that, but it is totally possible, and I have blog posts to show you how to do it. All right, so then what else do you have? Well, you've got tests. You're gonna write unit tests for stuff in core. Why? Because unit tests are super fast, they're super cheap to write, they only test one little piece of functionality. Once you get good at writing unit tests, if you're not already, they're so quick to do that there's no reason why you wouldn't just write a bunch of them for every little piece of business logic that you put in core. Right, all the pain that you get with testing usually comes from trying to test legacy code that has lots of dependencies. Writing tests for core that has no dependencies for me is kind of fun because I like to see it all light up green and tell me that everything's still good, and I like to see the number of green tests keep going higher and higher. That's telling me like I'm making progress. I'm getting closer and closer to fulfilling all the requirements that the customer has at the moment. You're going to have integration tests and functional tests for the web and for infrastructure. These names are a little less standardized, right? Integration tests could be any number of things. I use integration tests to mean code that has dependencies outside of my code, or it's testing a bunch of different things working together, like several classes working together. You might have integration tests on core that are testing several parts of your model working together, but you're gonna have most of your integration tests testing infrastructure, making sure that you really do save something to the database the way you expect, and you really do fetch it back, and you really can send an email, you know, even if you're faking it out, that kind of thing. And then functional tests, these are not quite UX tests, right? These are not running Selenium ideally. Those would be another set of tests you might write, but these are just testing the entire stack. They're testing MVC, the whole thing, but they're using a test server. So ASP.NET Core has great support for that. You can easily set something up so that you can test every endpoint of your API with every different possible error condition that it might have. And these tests, if you're using an in-memory data store, or even something like SQLite, they run super fast. So they're something that I would definitely encourage you to do. Okay, so that's pretty much the whole architecture from this diagram. Here's kind of what the folder structure ends up looking like. I usually have all my actual real source code in a source folder, and then I put my tests in a separate parallel folder, and I'd have tests for unit tests, integration tests, functional tests typically. And we'll look at that code in just a minute. So A couple of questions here. Are your guards addressed by code contracts? Sometimes they can be. I don't use code contracts strictly speaking in most of my applications, so they do have similar goals, but I use the guard clauses more so than I use code contracts. Andre asked, failfast is a good technique I'm using for a long time, but I've seen some people saying if a parameter is not supposed to be null, there's no need to check for it. If it's null, it's really an unexpected scenario. Adding checks everywhere increases code unnecessarily. What do you think? It's a question. Yeah, that I don't think you should necessarily handle all those checks everywhere, right? I have very few try catch blocks in my code, but I like to be able to say that the reason why this is failing is because this argument you gave me wasn't what I wanted, because it helps me later when I'm debugging, right? Or it makes it so I don't have to debug. Because if I see an exception that says, hey, argument null exception, I need an order to call this method, I immediately know where to go to find the problem, right? Where if I don't test it, I'm still going to get an exception, right? Somewhere inside that method, I'm going to say, set this thing to be order dot, order number, right? And boom, it's going to blow up. Why? Because order's null. Okay, well now I'm trying to find a null reference exception, right? And that's a whole lot harder, right? So I'm doing those checks because I want my job when something goes wrong to be easier. And yeah, I might have those checks in a couple different layers, but I don't have that many layers, right? I've only got a controller action that's going to call a service or an entity method, and then that's it, right? So it's not like I'm going through 10 different steps of checking null all the way through. And so if I have to check null a couple times in that whole thing, it's okay, I think, right? That's not an unreasonable price to pay. Now, if I find out that this one method needs to be super fast, I need to pull out all the stops, it needs to be as performant as I can possibly make it, and that null guard clause is adding 3 milliseconds that I need to squeeze out of it, then sure, I might rip out the null reference check there. But I'm only going to optimize for performance when I see that there's a performance problem. I'm not going to prematurely optimize for performance when optimizing for maintainability, I know is something that's going to pay dividends, right? And the performance might be good enough. And the performance is almost always cheaper to address by just throwing more hardware at it than by trying to micro optimize it with developer time, because servers are cheap. All right. Can train infrastructure by exposing extension methods to add service descriptions to iService collections so only the DI container can instantiate. Yes, exactly. I do that. Steve Gollin suggests there's various techniques you can do to make it so it's harder for developers to directly use stuff from infrastructure. You can use those extension methods. Most DI containers have this notion of some kind of a container or module or registry. They use different words for it, but you can put all the dependency wire up that you need for the infrastructure types in the infrastructure project, and then you can tell AutoFact to just scan all the assemblies for those modules and then run that code to wire them up. And the nice thing about that is the code to wire up those dependencies is in the same place as those services themselves, right? So you could have one that's in core that knows how to wire up all the core services. You could have another one that's in infrastructure just for wiring up infrastructure services, and likewise for web. So it's a matter of taste whether you like that or not, or whether you want them all to be in one place. But you do have options for that if you want. And I should of course mention, when we're talking about nulls in particular, that C#8 makes this easier because we have nullable reference types. So you should definitely start using nullable reference types, and if you are, then you'll need a lot fewer guard clauses for null. The guard clauses NuGet package that I talked about here, this actually works with nullable reference types. So if you say guard against null order, and then further on down you start using order, it knows that it's not null because it knows that that guard clause verified it wasn't null. So that's already smart enough there to know that after that point it's no longer null, and C#'s compiler will verify that. Would you use the not null annotation in method parameters for methods that don't have guards to make it self-explanatory why you didn't include guards? Yes, you could do that. Or even better would just be to use nullable reference types. So if it's a not null reference type, then it can't be null. And that's where I think you should be heading if you can. Do you split the code into feature per folder in case your core is too big, or just put everything together into the same folder? I would break it up into features. If I'm looking at my domain model, I usually break it up in the main model into aggregates more so than features. But I will use feature folders in the UI layer typically, and then in the domain layer, the core, I'll use aggregates, and then I'll use maybe features within that aggregate, right? So if I have certain domain events, I will start out probably with like a domain events folder, when it's really small. But as it gets bigger, I'll take the events that relate to a particular aggregate and I'll put them in that aggregates folder. If I have a guard clause that verifies that order is correct or something like that, I'll put it in the order aggregate folder, right? Not in just some generic guard clauses folder. So then when I'm just working on stuff that has to do with the order aggregate, everything I need is there. The events, the guard clauses, the exceptions, the handlers, all that stuff is in a folder related to that aggregate. And the aggregate tends to be the way that I group things in the domain model, and tends to be the way DDD does it. Related to my question with failing fast, there can be several methods across different objects which pass objects around. So I think the question is if you need to implement fail fast in all the objects or per layer, because I've seen code which is checking for null really everywhere. Yeah, I mean, you can check null everywhere. You can check null less if it's not a problem, right? Something I like to say in teaching developers is follow pain-driven development, which means if it's causing you pain, then take some remedial action to fix it, right? If it's not causing you any pain, don't worry about it. If it's not broke, don't fix it. So this is kind of a variation on Yagni from extreme programming, which says you aren't going to need it, which says don't build stuff just because you might need it, right? Build it when you recognize there's a problem. So should you use guard clauses everywhere on every method that ever takes something in? Only if you've discovered that that makes your code better and it makes it easier for you to reason about the code or to be sure that it's correct. If it's never been a problem for you, if you are certain that all you had to do is do model validation at the API layer and say these are required and model validation never fails, and so those things are never null, then don't worry about it, right? Just assume that it's going to be okay. But if you start banging your head against the wall because you keep getting these bugs with weird issues with null errors that take you like half a day to track down what was null, well then yeah, maybe guard clauses would have saved you a whole lot of time at that point. And so the idea here is to give you a bunch of patterns and principles and things that you don't necessarily have to apply all of them all at once. And I don't recommend that you do that. But the idea is that when you see the pain, you recognize it and you recognize that there is a way to fix it, right? So you have a tool chest that is full of tools that you know how to apply to address certain types of pain. And so that's the goal. It's with design patterns or with these architectural approaches. The reason I start with the principles is so that you can recognize what the overall principle is you're trying to get toward, and not necessarily try and code for all of those possibilities up front, but when you see some pain, when you feel the pain of not having that in place, you know what to do to fix it. So yeah, I wouldn't necessarily say you have to put a guard clause on every single method that might take null. And again, use nullable reference types, and then that problem largely goes away. Once you experience the pain of actually having to go through and touch every bit of code to make nullable reference types work, which is not trivial. But once you do it, it starts to be worth it. All right, I think I'm caught up on questions. So let me shift gears for just a second and talk about how you should structure your controllers themselves and the actions on your controllers. And I'm giving another talk for another UK user group tomorrow. And this is the only part that's really overlapping between the two, because this is really a sort of an API best practice that I've come to. But I think this is important, so I cover it in both. Okay, so let's say you have an API controller, or a standard MVC view, or even a Razor page that's got a handler, like an onGet handler. The typical thing that you're going to do in each one of these types of methods is you're going to accept some type through model binding, typically, and that's going to be in your argument for your action method or handler. You're going to perform whatever model validation. Right? You're going to say if model.isValid, or hopefully you'll just use a filter or an API controller attribute to do that. And then you're going to do whatever it is you're going to do. And you're going to create your response if you need one, and then you're going to return a result type with that response. Right? You're going to return a view with a view model, or an OK with an API result, or whatever it might be. That's the typical workflow for any given endpoint for an ASP.NET Core application. All right, so now let's talk about do work. What do we do there? What belongs in the action method itself, as opposed to somewhere else? So a really simple way that you would do an action method, especially for a CRUD service, would be that you go fetch the entity from an injected repository that corresponds to the thing that they're trying to work with. Then you work with the entity directly through its methods, and then you update the entity in the persistence, again, using that same repository. So this is great for simple operations. It works well for CRUD work. It works well when you have a domain model that is mostly encapsulated inside your entities, which is a good thing. That's how it should be. This does require mapping between your web models, your API model, your binding model, whatever, and your domain model in your controller, typically. And here's an example of what it might look like. So in this case, my API model is really just a primitive, right? It's just an ID. But that's what I get over the wire when they post, is they're telling me they want to mark item number 123 complete on the to-do list. All right, so in here, I'm going to go look up that item using a repository that was injected into the controller. I'll call a method on that entity, and then I'll update the entity in the repository so its new revised state gets updated in persistence. And then I return whatever. I return OK. In this case, I could return a DTO of the item in its new state if I wanted to. All right, so that's pretty simple. The downside to this approach is that there is a lot of low-level interaction here between persistence concerns, which the repository abstracts, but it's still working at the level of persistence and not working at the level of higher level services, which might be fine, but there's other ways that we can do it. So the next thing we might do is implement an application service. And an application service is going to take the work out of that action method and encapsulate it in another service so that my actions don't have to have quite as many dependencies necessarily. And instead of depending on a repository at the controller level, I can just depend on a service interface instead. And so I'll pass the API model type to the service. The service will do the work with the repository internally, and then it will return whatever my return type is. And again, in this example, my types are pretty simple. I'm getting in an integer and I'm returning nothing. So this is better for more complex operations. The application service becomes responsible for mapping the models, and it keeps your controllers a little more lightweight. And the code would look something like this. So now I would inject an app service into the controller, and I would just call its method. I basically delegate most of the work to it, and it does whatever it does inside, and I just return whatever it gives me back. In this case, nothing. But you can see I would just as easily return back a result that app service returned to me. All right. So then there's this third option, which is to use a tool like Mediator. And with Mediator, what you can do is not necessarily know exactly which service or thing is doing the work, but instead you just create a command that is represented as a message, and you send that message with Mediator, and it's something else is set up to handle that message. And so if you follow this approach, and this is becoming more and more common, Mediator, by the way, is another open source library that Jimmy Bogard, that we talked about earlier, works on. Actually, we did talk about Mediator, but AutoMapper, which we aren't talking about, is another common one that he's done. Okay, so here, same exact signature, right? I'm still just posting an integer, but instead of directly doing the work, or instead of directly invoking a specific service to do the work, I am just going to create this command type with that logic that came in, and I'm going to call send, and then whenever that completes, I'll return OK. And still, if I needed a result back from this, like the current state of the item, this could return a result just as easily. All right, so what does this do for you? Well, now inside of my controller, what do I need as a dependency? I don't need to have a repository of to-do item. I don't have to have a to-do item app service. All I have to have as a dependency is iMediator. And every single controller, if you follow this approach, has the exact same constructor dependency. They all just depend on iMediator. And so what that means is you could just have a base controller that has an iMediator property on it, and you can get rid of all your constructor injection from every controller and instead replace them all with just this base controller that knows about iMediator. And it really cleans up the dependencies on your controller quite a bit. Now, if you look at this code, it's still going to be a little bit duplicate, as you go to every single action method and they all look like this. That first line where they're creating the command, we don't really need to do that inside the controller. Our controller can actually get smaller. Our action method can get smaller, because I can use model binding, and I can just say, you know what, let's just say the command is the thing that I get off the wire, right? And as long as I make sure the command has the right named properties on it, then model binding will give me that command with that ID on it. And now I can just say mediator.send whatever that command is. Now, when you use Mediator like this, you're going to have another class somewhere that's going to be the handler, and the handler is going to do the actual work of whatever it did, right? That's where the repository might be injected, and it's going to go fetch the thing and call the method and save it. That all lives in the handler. Okay. Now, it turns out that you can actually do largely the same type of thing and get the same benefits. And what is the benefit? Well, the benefit is single responsibility principle, big time. All right, if you look at a controller that's built using this approach, or it's built using this approach, it is not at all uncommon to see a controller on an API that has 10 different dependencies, because it's got 3 different repositories and 2 different loggers and a way to send email and this and that and the other. And the constructor just goes out of control. And a bunch of those dependencies are only used by one action method, right? And it's got 6 or 8 different action methods for different endpoints for how it does things, but they're not really related to one another except for the route, right? None of them ever call each other, typically, right? So they're not very cohesive as an object would go. When you start going down the mediator path here, and you end up with this, your controller is way more cohesive. It's just a list of endpoints, right? And it's the handlers that each do one thing. They follow a single responsibility much better. And they very frequently only have like maybe 1 or 2 dependencies, because any given endpoint doesn't need that many different services that it's working with. And so it gets a lot smaller and easier to follow. Typically, every API endpoint at that point fits on your screen, the whole class, not just the method, right? Because you've got just that handler, and it has one method in it, and whatever its dependencies are, it's real small. You can actually do this without using Mediator, using a library that I've got called API endpoints. And I've built that into clean architecture as an option. So I'll show you that right now. Let me just get a drink of water and make sure I'm up to speed on all the questions, and then I'll start showing you some code. All right, a couple questions. Somebody called out my talk tomorrow, thank you, at the Milton Keynes, I think I'm pronouncing that right, meetup. Saad asks, would you create a separate parameter class if the number of parameters are increased and do guard checks in it? Possibly, yeah, using a parameter class is a good refactoring if you have too many types. Sometimes that's just hiding the problem. Like if the types are related to each other, then it makes sense. So, if you've got a bunch of arguments coming in and they're like start date, end date, okay, well those go together, right? They're talking about the same thing. So sure, put those in an object. But if you have a controller and it has like 10 different arguments, and it's like 4 different repositories and a validator and an email sender and 2 loggers and whatever else, like none of those things necessarily all go together. So just creating a parameter object just so that you can make your list smaller is kind of hiding the problem, right? The real problem is you're doing too many things. You're violating single responsibility. And if you fix that problem, the number of dependencies problem goes away on its own. So yes, I would use that approach, but I wouldn't just always use that approach. You need to make sure that you're putting them together because they logically belong together. With the mediator approach, where would you recommend placing the command handlers? Excellent question. I would put them as close to core as I could. So if they depended on web stuff, I would have to put them in the web project. But if they didn't, then I would put them in core because then they're more testable, right? And so now I've got these handlers that are responding to different endpoints or whatever. But I can put them inside of my core project and make them much more unit testable. All right, so let's shift gears over to Visual Studio, and let's look at clean architecture first. And we'll just close all these things down for a second. And so in here, looking first at the solution structure, we have 4 different projects. I said there'd only be 3, but that's because in the solution structure, I'm assuming you don't already have a shared kernel NuGet package. And so I put stuff that normally would go in shared kernel into its own project here. And so what you would typically do is rip this out of the solution, put it in its own solution, and then publish it as a NuGet package. And it would have all these shared things in here, all these base types and stuff. And then your first clean architecture solution would depend on that NuGet package. And then if you made more of them, they would depend on that same NuGet package. All right, inside of core, the idea with this is that it's not meant to be a sample application. It's not meant to be a full-fledged app that you can kind of see how everything works. That's what eShop on web is supposed to be. We'll look at that in a second. This is meant to be a template, right? So it has enough stuff in here that you can kind of see how things work. But the idea is that you just rip it out and replace it with your own stuff. It's kind of like when you say file new class library, they always give you that class1.cs, even though no one ever names a class1, I hope. So the first thing you do is delete it or rename it. That's the idea here too. But I recognize that there's a bunch of patterns and stuff that I'm using here that maybe not everybody understands at the start. So there's some like very basic implementation of these patterns in here as well. All right, so here's an example of an entity. This to-do item, similar to what I was just showing you that action method might deal with. It is encapsulated, so whether or not it's done is not something you can just arbitrarily set, because there's business logic that should happen when an item is completed. What business logic? Doesn't matter. There's something should happen when this thing gets completed. And so the only way to complete it is by calling this mark complete method. And when you call mark complete, it sets is done to true, and it queues up an event. It just adds it to a collection. Now, where is that collection? That's actually on base entity. So that's one of the few things that's on base entity is this collection of events. And so if we go look at base entity over here, you'll see it has to have an ID, and it has to have this list of domain events. Okay, so then when we save this entity, what's responsible for doing something with these events is actually an override on the DB context. So if we go look at infrastructure, that's where all our data access is. Inside this data folder, there's an app DB context, and you'll see if you scroll down here that we're overriding the save changes async method. This is where the domain events get implemented. And you don't really have to care about this except to know that it's here. But you don't have to worry about this code. It just kind of works behind the scenes. In fact, you can even replace a lot of this code here with Mediator. So if you're already using Mediator, you can swap that out. I've been trying to keep down the number of dependencies that this template has, but I'm thinking I probably will in a future version just use Mediator, because it'll get rid of the total amount of code that I'm using here. But basically what this code does is it says, go through all of the entities that we're saving and find any of them that have events. And then go through those events and dispatch them. And when you dispatch an event, all it does is it scans through all the assemblies, looks for anything that has a particular interface called iHandle of T, where T is that event type, and then it calls that handle method. So it does this after it saves. This is important. So this domain event, it's just a pattern. So there's different ways you can implement the pattern. This pattern fires those events after you've successfully saved your model. So if you want to send the customer an email whenever they check out, it's a good idea to make sure you save their order and then send them an email. Because if you send them an email first, and then you try to save their order and it fails, and you don't actually save the order, then the customer just got an email that said, hey, we got your order, great, look for it in a few days. And a week later, they're calling you saying, where's my stuff? And you're like, I don't know, I don't see any order, right? And then depending on how good your logging is, you may have no knowledge that they ever made that order. So important here is that we're gonna save the state first and then fire off the events. An example of an event handler is right here. So this is an item completed email notification handler. And what it does is just what I said, it sends an email in response to something happening. So this domain event comes in. I am doing a guard against null here, although probably it would never actually be null, but it was just another opportunity to kind of demonstrate how to use guard clauses. And then in here, it's gonna send an email, not through a direct reference to system.net.smtp or whatever. It's using an interface for that. And the interface implementation is defined in, you guessed it, infrastructure. So there's an email sender here that actually talks to an SMTP client to send the email. All right. And so that's kind of how the architecture works at the infrastructure and core level. If we look at the web project, there's a few different implementations here, and the idea is you'll rip out the ones you're not using. So when you do a file new ASP.NET Core project, you see that there's options for like empty, API, Razor Pages, MVC, etc. This has an API set of endpoints. It has a set of controllers you'd use if you're using standard models and views, and it also has Razor Pages. Oh, by the way, it also has endpoints, which we'll talk about in just a second. So there's 4 different ways that you can do stuff here. Basically, 2 of them are for view-based logic, and 2 of them are for API-based logic. I'm a big fan of Razor Pages if you're doing view-based logic, because some of the questions came up in the talk. Do you support feature folders? Yes. Well, guess what? Razor Pages kind of supports feature folders out of the box. If you want to have all the stuff related to a particular feature, you can put it all inside of this Razor page, right? So this Razor page here depends on this model, right? Well, if this were a view and I were using the standard folder structure, that model would be in another folder somewhere called view models, right? And to find it, I'd have to go scanning around inside of my solution structure to go find some other folder to go find that type that goes with that view, right? Very rarely do I see anyone putting the actual view models in with the views, although you could. Razor Pages actually change these things together like this, so you can actually just, expand the tree view and look, here's the model that it goes with, right? This is the model for that view, or for that page. And so they already have this like organizational pattern that's better than MVC has, because MVC you tend to have your C is way up here under controllers, your V is way down here under views, and your view models is somewhere in between, and you end up having to spelunk all through your solution tree trying to find those things anytime you work on a particular feature. Razor Pages fixes that. Okay, but what about for APIs? Here's a to-do items controller. It knows how to list and get and post to-do items. It's using these to-do item DTOs. Well, where's that? Well, that's in my API models folder, because that's how you do things with APIs, right? This is not as bad as with views, because you only have two things typically. You've got your controller and you've got your models, which are usually in two separate folders. But again, this can benefit from the same notion as Razor Pages. And what's more, like I mentioned to you, these controllers often get out of control with how many different actions they have on them. This one's only got 4, but in a real application, it's not unusual to see controllers that are hundreds of lines long doing just way too much stuff. And why is it all in that one controller? Because the route, typically, right? Because it was easy to make it all under one route. And so what you can do with API endpoints is you can break that up into one class, one endpoint per action that you're taking, right? So if I want to create a to-do item, I can have a create endpoint, and this create endpoint has my verb, and here it has some Swagger details that I've added just to make Swagger a little prettier. And then all the logic is just right here. Right now, if this has any DTOs that go with it, like a request or a response, those are defined here, right? So this is an endpoint of request comma response, and it takes in this request and it returns back this response. And where are those? Oh, well, they're right here. They're chained with it, right? So I can just expand this and see those types that go along with it. So each one of these endpoints has all of its models right with it. And so for me, that makes it really easy to think about just one thing when you're doing this work. Instead of having to jump around and look at a really long controller and scroll down to the actual endpoint or action method that I'm concerned with, I've found that this endpoint approach works really well. And so these are actually coming from this base async endpoint. They're coming from another NuGet package, which is this Ardalis API endpoints package that you can go download, and it's on GitHub. All right. Robert asks, where's the place to host HTTP clients calling external APIs necessary for the domain services? The interfaces for those would live in core, and the actual call would go inside of infrastructure. So this email sender I implemented so that it's like literally just talking to localhost SMTP. But let's say I was using SendGrid, which does have an API. I would have a SendGrid email sender, I email sender, and all the logic for talking to SendGrid would live inside of the SendGrid one. And then at runtime, I would just pick which one do I want to use, or I'd have some logic to fall back, right? I'd say, well, use SendGrid, but if I'm running in the integration environment, then use localhost because I don't really want to send emails, right? So that would be an option. Where I would be applying if I want to apply a duplicate check for the title from the database. Good question. So where do you put logic that isn't something you can just do in model validation? So let's say, here's my to-do item DTO. I can do model validation on things like required, but I can't do something on here that says, not duplicate, right? That doesn't work because how do you know it's duplicate without talking to the database? You got to do some kind of a call in there. So where you would know that is typically going to be lower inside of the API. So you would do those types of checks. For me, I would write like a Fluent validator. I'd do the validation inside of core, but it would depend on some kind of infrastructure, right? Because it has to actually talk to the database. So I might have a repository that returns back a count or an exists or something like that. It's a fairly efficient way to get the answer to that question of does this title exist already? And I need to look for a count of 0 or an exists of false. And that call, that logic would live inside of a validator somewhere inside core. That validator would look like this, would look something like this in that it would have a repository or something here that was an abstraction of how to get that information back from the database. And then in here it would say, go hit the database and see, does this title exist? And then throw an exception if it already exists, or return a result if you don't want to throw the exception. Sometimes it's a gray area as to whether or not you want to use an exception to represent something that's not valid, or just a return type, right? In the case of a name already existing, it's probably not exceptional if it's, like let's say you're registering for a new Twitter account and you want to find a Twitter alias that's not already taken. Checking for a Twitter alias and seeing that it's already used by someone else probably isn't exceptional, right? Probably the first few things you check are already used by somebody else at this point, because there's so many of them out there. And so it probably makes sense to return back a false or something that says it's not available, not just blowing up with an exception. But other types of validation, maybe it makes sense to throw an exception because you never expect to hit that in your logic that you've allowed for in your app. And so that's the logic that I use to determine whether or not something should be an exception or not when I'm doing validation. So hopefully that answers your question. If you wanted to pull that out in such a way that it was reusable or something like that, first I would say Fluent Validation is my go-to for that type of validator. It's another NuGet package. It's not one that I wrote, but if you haven't used Fluent Validators, they're really we can pull it up in a browser here in a sec if you want. And then I would implement the validation there, and it's just a matter of where you call it from. You could implement it with a filter if you wanted to. So you could put the logic back out on here, and you could create a filter here that would do it. I wouldn't typically do that because I don't necessarily want that to be a validation on the model. I tend to think about it differently about whether or not this request is well formed, right? That's what this model validation is checking is this well formed? Whether or not this title exists in the database or not is not a question of whether or not this message is well formed. It's a separate question, right? It's a business logic issue that's in the back end. And so I wouldn't put that logic for checking for duplicateness here. I would put it in the back end. I'd put it in the domain as part of the logic of creating the thing, or checking to see if I can create the thing, if that helps. All right. Let me just run this real quick so you can see that it actually works. And I can hope that it actually works. The URL for this, I'll pull that up in a second as well. All right, so, and I'll paste it into the chat. So here it is running. And that's not actually it, but it should get us there. There's my GitHub account, and there's Clean Architecture is the very first one. So here, I'll throw this in the chat for y'all. So that's where you can find it. And it's only a few stars away from 5,000, so you should start. In here, you can kind of browse around and see it. And for those of you that don't know how I'm doing this, this is a really cool Chrome extension called Octotree. So you should get that because it gives you like a solution explorer inside GitHub, which is amazing because it's way nicer to do this than to have to click in here all the time, because that gets old fast, especially when you want to bounce between a couple things. It's really nice to have this tree view. So that's Octotree. In the sample itself, it looks like this. The main thing that you would look at is the Swagger endpoint. And so here's what Swagger looks like. And you can say, give me a list of all the items, and I'll try it out, and I'll execute. And look at there, I've got these three things. And I've run this sample a few times, so a couple of them are marked as true from previous demos. Item 3 is marked as false. Let's go see real quick what happens when I mark that as true. So I can go to this to-do items controller, and we can expand on this a little bit, and we can put a breakpoint right there, and then we can hit F5 to debug, and we'll go step through the code so you can see how the events fire. So there it's running. There it is again. You go to the API documentation. Those are endpoints up there. This is the controller down here. So I want to do, I want to complete here number 3. So we're going to try it out and complete number 3 and execute. And we hit our breakpoint and we step over, and now we've got to do item number 3. Says it's not done. Run and review the tests. And we step over that. We call mark complete. Nothing really happens at that point. And then we'll, let me go put a breakpoint. I should do a breakpoint, otherwise I'll step over and it won't work. Let's go over here. Let's find this handler. So there's this handler. We'll put a breakpoint right here, and then we'll come back and just continue. And now we hit this breakpoint now on the handler. It's going to check whether it's null, and it's going to try and send an email, and it's going to blow up there probably because I don't have an email server running. And so here it's going to blow up with a 500, and it says socket exception, can't find the email server. And to that, I will say, hey, let's run SMTP for dev, which is a nice developer server. No, I don't care about that. Allow access. And so this is going to run, it's going to listen on port 25 for emails. And so my thing is complete because I actually ran it, but just the email failed. So I can't mark it complete. Well, actually I can. I don't have that logic to say I can't mark it complete twice. So let's just mark it complete again. So we'll execute again, and we'll continue, and we'll step here, and we'll step here, and now it's going to work, maybe. And now we continued stepping, no exception, continue. And let's look at SMTP for dev, and here it is. And it says, hey, run and review test was completed. And you can double click on this, or you can view it. No, you can inspect it. When you double click on it, it wants you to open Outlook, which I don't want to do, but this lets you see it. So here's the body of it. So tools like SMTP for dev are really nice for testing local email. And I've got a blog post I wrote recently about that. There's a few different tools out there. You can actually run another similar tool as a Docker container that works really well called Papercut, and then you can just run that in Docker if you're into using Docker. So there's that. All right. So any questions about clean architecture? The last thing I want to show before we wrap it up is eShop on web, which you'll see is similarly architected, but it's a full reference application. All right, so let's jump to that. Let's shut this down. And here's eShop on web. Let me just run it first and show you what it looks like, and then we'll go through the code. So here's this electronic shop. It's on the web, hence it's eShop on web. eShop on web is a reference application from Microsoft. It's free, it's open source. If you Google for it, you'll find it right away. It's right there. And there's the book that I mentioned right here. You can grab, or you can just read it on Microsoft's Docs website as a series of articles in their documentation. There's a companion book and application that goes with it called eShop on Containers. We'll look at eShop on web in a second, but you can see right here, it's basically 3 different projects, right, plus tests. So it's pretty simple. The idea is that it's a monolithic ASP.NET Core application, pretty simple architecture. If you want to see how to take this and break it up into microservices using Kubernetes and Docker, then eShop on Containers is where you want to look. And it is a little bit more complicated, right? It has separate individual microservices for managing your shopping cart, your product catalog, your identity, your location, some marketing stuff, how you place an order, how you do payment, how you do this, how you do that. It's got different web front ends for MVC versus Angular and other stuff. There's a whole lot of complexity. It's got API gateways and Azure things in here. So if you want to see like enterprise architecture, how do you do this with as much moving parts and complexity as you can, check this out. Developers love complexity, so there's 14,000 stars on how to do it the really hard way. There's only 4,500 stars for people that want to do it the easy way that you'll get done sometime this month instead of in a couple years. But they're both good reference examples of how to build these applications with Microsoft technologies. And yes, I do help clients that do stuff with microservices and all the complexity, and it's warranted in some cases. But most of the time it makes sense to start with a simple monolithic application that's modular, and then identify the places where it makes sense to break that up into separate services. Okay, so that's where you can find the code. Looking at the code, I already mentioned it's pretty similar in terms of layout at the high level. It's got the same 3 projects. It's got the same 3 test projects. You can run eShop on web in Docker. It's just not broken up into 10 different Docker containers running in Kubernetes clusters. Inside of core, it has a number of different entities broken up into aggregates, like I mentioned. So for instance, there's the order aggregate that has the order with its order items and some related things. It has custom exceptions for stuff like basket not found and different guard clause, custom guard clauses. It has interfaces in here. It has some domain services, and it has specifications. I did mention specifications are a pretty cool pattern. You'll see a good implementation of them here. If you've ever had an issue where inside your controllers you have a lot of lambda expression logic for filtering or defining what you're going to pull back, like the shape of the data, if you're using EF and you want it to include this and include that, this kind of eliminates a lot of that also. If you have repositories or you're using DB context directly and you're returning iQueryable back, and then you have application services and you have controller actions, and maybe you even have views with logic on the view itself, all of which are modifying that query, then you basically have your data access code just split everywhere across your application. You have no separation of concerns for data access. And it has some benefits, right? Because you're able to modify that query anywhere up the stack, but you do have that problem of just no encapsulation of that logic. It's just everywhere. So specification eliminates that problem. So here we have a specification for catalog filter paginated specification. Where is that used? Well, on the home page, here, way back here, on the home page, this is a filtered list of products that also has paging. Right, so this is showing page 1 of 2. You can hit next and see the next page, or previous. You can filter it and say, I just want .NET, I just want coffee mugs, and filter it down. Now, all that logic is here, right? So I don't have a big controller action that has a whole bunch of logic for how to do skip and take and filter this and filter that and a big lambda. The only lambda expression is right here. It says, hey, give me items that the brand value matches this and the type value matches that, and then, hey, apply paging. Right, that's it. When I want to call this, the code is really simple. So in the web, on the default page, it's page index here, it says on get, go get the model by calling this catalog model view service, get the items. That view service is returning back a view model. And so because it's returning back a view model, that service needs to live in the web project. I can't return a view model from core because core doesn't know about view models, right? That's a web thing. And so this service lives here in core, and there's this catalog item view model service, this one. And so this one just knows how to do all the things with paging and whatnot. It makes a couple different calls to the repository, to list and to count, because those are slightly different, right? When I want to get the count, I need to get all the items. When I want to just get the list, I only want this page's worth of items. I only want the 10 items that are on this page. And these are both highly cacheable, and this is using a cached decorator around that service, so it doesn't actually hit the database every single call. In here, it just does a mapping to create the view model from the stuff it gets back from the domain model, and then it returns back the view model when it's all done. So where's the actual code that does the repository call? Well, that's in this item repository list async. So if we go at infrastructure and we look at our EF repository, we have a generic repository here that knows how to work with any base entity as long as it's an aggregate root. So you can only use a repository to fetch a full aggregate. You can't use a repository to fetch back like an order item, right? Because an order item doesn't make sense by itself. You have to get it as part of the order so that you can check all of the business logic that has to do with that order. In here, when you want to do a list with a specification, you just pass in the specification, it applies it, and it calls toList async. So this apply specification is just a helper method down here at the bottom. It news up, or actually it's a static call to this specification evaluator.get query, and it does the work. And let's look at that here. And so I mentioned iQueryable. I don't like to return iQueryable from my repository because when it leaks out of the repository layer, you end up with your data access code spread all over your app. But it certainly makes sense to use iQueryable inside of your infrastructure layer to further compose your query before you execute it. And so that's what this is doing. It takes the specification and it takes an input query, which is usually just a DB set, and it returns back a modified query as the result. And so it applies the criteria from the specification. It applies all the include statements from the specification. It does ordering, it does grouping, it does paging, and when it's done, it just returns back the query. And so because of this little helper and the use of the specification pattern, the repository is this long, right? That's the whole repository for every entity, for every aggregate in this entire application. Right now, there's only, like 10 of them, but there could be 100 different aggregates in here, and it would still only need this repository to do all of them. Okay. So I think that's pretty cool, and it helps quite a bit to keep your repository from getting bigger and bigger and bigger with different custom methods on them. Now, there is one other repository in here, but that's really just to show an example of how you might do it, and that's this order repository, and you can say get by ID with items. And so you can write code like this, and you can have a repository that inherits from the generic repository. But you don't need to do this if you use the specification pattern. This is like an option. If you don't want to use the specification pattern for some reason, you could do it like this. But it's not as good of a solution in my opinion. All right. Let's look here. Where did I play? Okay, duplicate check. How are the mediator links set up? I don't see any, I don't have any mediator links in here, so I'm not sure what that's referring to. I prefer the easy way because I like to see the sun. Yeah, the easy way of building applications like eShop on web versus eShop on containers. I agree. I would start with the easy way. You mentioned scanning the DI setup using AutoFag. Is it possible to move the DI registration code out of Startup CS when using the built-in DI in C#.NET Core? Not that I have seen. Someone somewhere has probably done it, but I haven't seen it outside of a third-party DI container. So the question is, if I come down here into startup.cs for this thing, and we do like configure services, and here's all my configure this basket service, right? So this is not using obviously like any sort of reflection-based thing with AutoFac or whatever. This is using just the built-in DI container because this is a Microsoft sample. We're trying not to add too many third-party things and stuff to it. But you could take this logic and put it into a registry or a module or whatever it's called, and drop that into infrastructure, typically in the root of the project. And then in here, I could say, services or autofac.load assemblies, and I would say, give me the core assembly, give me the infrastructure assembly, give me the web assembly, and I would say scan for registries. And it would go find all those registry classes in those other projects, and it would run them, and inside of them it would do this work, right? Can you do that with just ASP.NET Core's DI? Not that I've seen. You could probably write your own reflection code in here to go find all that stuff, I suppose, or do it yourself. I mean, you could write code to do it, but I haven't seen anything that's easy and elegant to do it with. Not keen on assembly scanning, but Scruder does it. Yeah, so Scruder is another option for doing that type of discovery of types. And all the different DI containers support it too, whether it's structure map or autofac or unity or ninject or what have you. They'll all do that too. Okay, that is pretty much it. There are no domain events in eShop on web, although you could certainly add them. There are no specifications in clean architecture, although I plan to add them at some point. If you want to use specification and you don't want to have to rip out all that code I just showed, you can actually just go look for ardalis.specification and grab it from NuGet. So this is the GitHub page for it, and this is the NuGet page for it. And so you can just grab it and use it. And what this includes is the base type and the evaluator. And if you look in here, you'll see what the sample, somewhere there's a sample of how to use it. Maybe I just put it all in the tests. The other thing that's in here that's kind of cool is this run test script that will actually spin up Docker containers. Is it Docker Compose? So what this will do is it will spin up the tests, and the tests depend on the database. And I can't just use, link to in memory because the specification has to actually translate things like .include correctly. So let's look at an example of that. So in a specification, you might have something like basket with items. So I'm going to add include for items. So I'm going to get back the shopping basket, and the navigation property of the items needs to also be populated. By default, Entity Framework won't do that, right? It'll just be null unless you tell it with eager loading to include those things. You can even do multi-level. So here you can say add include for order items on this order, but then also include the item ordered off of order items, right? So you can have it go as deep as you need it to go. That affects how the SQL is generated that Entity Framework uses to run a query against the database. But it only works when you're talking to SQL Server. It doesn't do any of that if you're using an in-memory database. Instead, it just gives you back the objects, right? And these things are never null because they're actually objects in memory, so they're there. So to test that my specification works, I needed to have a real database. And so this actually shows you how to do that kind of integration testing with Docker by having a real database that's running in a Ubuntu container on here. And so when you run this, it spins this up, spins that up, and it populates it, and then it runs all the specification tests against that Docker container database, and then it spins it down. So you don't have to have a database installed. You just have to have Docker installed. All right, so, and that's here. And I've got a few other packages. If you just go search NuGet for Ardalis, there's some other good stuff in here that you may find useful. But specification is a good one. We talked about guard clauses. It's probably my most popular one. And then the clean architecture repo itself is a good starting point. So, any other questions? I think I'm close to done, close to out of breath. Here's some more resources, some more stuff on Pluralsight. I showed you all these links at the start. I do have a clean architecture for worker services also. So if you're ever doing a worker service, not an ASP.NET endpoint or project, you can use that as your starting point for building worker services to deploy somewhere. And I'll stick around and answer questions for as long as you like, but that's what I've got to share.
Cool, thanks.